Example 1, at 8 p.m. Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m. Hector's headed south from the same camp. If Hector was 50 kilometers ahead by 3 a.m., what was his speed? So, they're both heading south. South is down. So, let's start with camp being right here, and Achilles and Hector. There's the two characters. All right. Who goes further? Hector. By how much?
30 kilometers. No, wait.
50 kilometers. Yeah, 50 kilometers ahead. All right. So, when I'm drawing distances, what I want to draw is how far they went in relation to each other. I don't know how far Achilles or Hector went, but I know that Hector went more by 50. So, if I draw Achilles going south some distance, and I'll put d sub a to represent Achilles' distance, I'm going to draw Hector's distance line longer because he went further. I don't know his distance either, but I do know Hector's ending point, Achilles' ending point. I know that distance there is 50 kilometers. When I draw this picture, there are no speeds or times included because they don't matter. They're both moving, they both went some distance, that's all that matters in this picture is distance. Looking at the picture, I can see that if I take Achilles' distance, add 50 kilometers, I'm going to get Hector's distance. That's what I need to get out of that picture, and that's job 1 in these problems. How do the distances relate to one another? That's all you care about. Next thing we do. Our two characters are Achilles and Hector, so I put them in their rows. And what I care about now is how fast and how much time do they travel. So I got rate and time in these boxes. And my job is to fill in these 4 boxes here from what I read up here in order to create expressions over here that are distances. All right. So at this point, once I figure this out and I go to this chart, what I'm focusing on specifically is these 4 boxes here. Rates and times of these two characters. I'm not going to get anything about distance whatsoever from this chart, from this problem. Okay, I'm saying some of you putting 50 in here, because 50 kilometers is distance. You want to put 50 somewhere. This is where 50 goes, right here. It does not go in the boxes up here. So at no point in time, at this point, are you going to get anything out of this problem into this chart. The only thing that goes into this chart from this problem is how fast they're going, how much time it took them. You do not fill in distances from this chart. So, how fast is Achilles traveling?
20 kilometers.
20 kilometers per hour. The fact that I know it's kilometers per hour, I'm going to put kilometers per hour here. I'm going to put hours here and kilometers up here. Okay, don't put 20 kilometers per hour down here. Just put numbers in the chart. It's easier. Numbers and letters go on the chart. Rate or units go up here. All right. How fast is Hector going?
We don't know.
We don't know. So I'm going to use a letter to represent his speed. I usually like to use letter R for rate, T for time. Okay? The fact that we used a variable in the rate column tells me that I should know the time of each of these people. So what they're telling me is time of day. 8 p.m. is when Achilles left.
Should be 8?
No. His time is not 8 because 8 p.m. is what time it is on the clock. The question is how much time has passed that he traveled. So this is his starting time, right?
Yo. Oh, yeah. There.
And his end time is 3 a.m. So how many hours passed between 8 and 3? 7 hours. So Achilles' time is 7 hours. What time did Hector leave?
10.
He started at 10 p.m. What time did he end?
3.
Also 3. How many hours is that? 5. So be very careful with time. Time is always elapsed time. How much time passed? Not what time it shows on the clock. All right? So again, these 4 pieces of information, number, 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 unknown, that's what I get from the reading. And once I know all 4 of these things, I multiply rate times time to get distance. 20 times 7 is 140 kilometers. R times 5 is 5R kilometers. The way I get these 2 boxes filled in is I simply multiply the 2 boxes over there together for each character. This is D sub A, and this is D sub H. Achilles' distance, Hector's distance. We have expressions or numbers representing both of those things. We put them into our equation. 140 plus 50 is equal to 5R. Which means that 190 is equal to 5R. We divide by 5, we get R is equal to 38.
Yep.
Okay. And R is in this column here under the heading of kilometers per hour, right? So what was his speed? That's the speed, and the unit of speed is kilometers per hour. The only other thing we didn't know was Hector's distance. We need to know Hector's distance. It's 190, isn't it? 5R equals 190. 190 kilometers, or 38 times 5 if you wanted to. You would have gotten 190 that way also. That's how to do these problems each and every time. Distances go in the picture to create the expression, the equation. The reading allows us to find these four things, either specific or abstract. Multiply rate times time to get distance expressions that go into your distance equation to solve for the missing variable. And then, of course, answer whatever question they're asking. In this case, what was his speed? We found his speed, so we're done.